This video is for Chapter 8, Lesson 4. And in this lesson, students will represent functions using equations, tables, and graphs. Please get your materials together and open your textbook to page 403. Today we're going to be working on representing functions using words and equations. So it's kind of a throwback to Chapter 6 when we wrote algebraic expressions. We had to have a variable, a math operation, and a number. But today we're going to be working with equations, so we're going to introduce the equal sign. So we'll be working with story problems today to write equations. A runner's distance in a marathon is equal, so we're talking about the distance, is equal to 8 miles per hour times the number of hours. So we can make this into a math equation that's to find out the distance that we travel is equal to 8 times the hours that we run. So in general, words and equations can be used to describe functions. And remember, that's kind of like our rules. Okay? For example, when a rate is expressed in words, it can be written as an equation with variables, like we did up here. When you write an equation, determine what variables to use to represent the different quantities. So in Chapter 6, we only had one variable. This time, we're going to have two variables. One will be on, we'll have a variable on either side of the equation sign. So let's look at example 1. The drama club is holding a bake sale, and they are charging $5 for each pie that they sell. Write an equation to find the total amount earned, which they told us to use the letter T for total, and for selling the P number of pies. So in words it says the total earned equals 5 times the number of pies. But just like back with our algebraic expressions, we're not going to use x here to show multiplication. Okay, so we need to use this one, or we can use this the dot. So our equation is going to be T, the total amount of money, is equal to 5 times P. And remember, that's what in our algebra, when we have a number next to a letter, it means multiply. Number 2. In a science report, Maya finds that the average adult breathes 14 times each minute when not active. They would like us to write an equation to find the total breaths for a non-active person in m minutes. So I see my 14, I see the two variables, and here's our math word right there, talks about multiplication. So our total number of breaths will be equal to the 14 times the m. For every minute, I'll get 14 breaths. So we can represent these functions using tables and graphs. So going back to that distance is equal to the time that we had a couple of pages ago. We're talking about putting in, if in 0 hours, I will travel 0 miles. So that's 0.00, and they put it on the graph. If we walk for 1 hour, we'll have traveled 8 miles, so have 0.18. So tables and graphs can be used to represent our functions. And remember that word functions means our rule. It's our in and outs. Example 3. Student council is holding a car wash to raise money. They are charging $7 for each car that they wash. So our work here is to write an equation and make the function table to show the relationship between the number of cars washed, C, and the total amount of money earned. So we have to have the T and the C on opposite sides of our equal sign. And then the 7 now has to come into the equation. So is it 7 times the total? Nope, that would not make sense. So it's going to be 7 times C, 7 times each and every car. And now they took this information and they filled in the chart. That if we washed one car, we take 1 times the $7 and get $7. If we wash 2 cars then, we take 2 times 7 and we'd get $14. And if we wash 3 cars, we would get $21, and so on. And if we wash 4, 28. So remember, this is kind of like our x-axis, the input, and the out, which stands for y, and this is our rule or function here in the middle. So now we're going to analyze this and graph the ordered pairs. So going back to the chart on the back page, if we washed one car, and you guys don't have to make this chart, if we washed one car, we made $7. 2 cars, we got $14. 3 cars was $21, and 4 cars was $28. So these create our ordered pairs, remember? 1, 7, 2, 14, 3, 21, and 4, 28. And these are the points then that they plotted. If we have 0 cars, we'll make 0 money. If we wash one car, we make $7, so our point 17. We have our point 214, 321, and 428. And we know we're doing a good job because we're creating that line, because we're working with linear algebra. So let's try this got it. While in normal flight, a bald eagle flies at the average speed of 30 miles per hour. Write an equation and make the function table to show the relationship between the total distance d that the bald eagle can travel in h hours. So I know right away that I'm going to have d and h in my equation with an equal sign between them. And now I need to decide, where is this 30 going to go? Well, we're going to go 30 miles for 1 hour, so we're going to take 30 times h. Because I don't need to take 30 times the distance. It's 30 minutes or 30 miles per that 1 hour. So now if you look at our chart, they haven't asked us to, they didn't give us any of the inputs or the outputs like they did in lesson 3. This time we get to pick whatever we want. And a little bit different here is they turned the chart sideways. Instead of having it vertically with our hours and our distance traveled this way, they turned it horizontal. So we just need to be careful and remember that our hours is actually our x, our input, and our out is down here as our y. So we can pick whatever we want to. And looking at my graph, I should probably pick hours between the numbers 1 and 9 because otherwise my graph is not going to be big enough to hold it. So I'm going to keep it simple. I'm going to say that after 1 hour, the eagle then will fly 30 miles. Now noticing at this chart, they don't have the rule in the middle to show our thinking. We're just going to have to fill it in and be doing that in our head. So remember, our rule, or the function, was 30 times h. So if I fly for 2 hours, the eagle will travel 60 because I'll take 30 times 2. And if I let the eagle fly for 4 hours, and remember I can just pick whatever I want, 4 times 30 would be 120. So before we go on, then we should make our ordered pairs. So my first ordered pair then is right here. And remember that the x value goes first, and the x down here is with the hours. So that's how I knew that this was my inputs here. So it'll be 130, and I can plot that on the graph. I go from 1 up to 30. My next point is 260. So I go to my graph, go to 2 and up to 60. And my third ordered pair would be 4, 120. So I go over to 4 and up to, oh goodness, I go off the chart. So I'd have to kind of estimate. Now I'm thinking, maybe I made a poor choice. Maybe I should go back here and erase. Maybe I should just go back here and do 3 instead. Let's see if it stays on the graph better for me. So if I put in 3 hours, I'll travel 90 because it's 3 times 30. So my point would be 390, and yep, that works better for me and keeps me on my graph. And now I know I'm doing a good job because I'm able to draw a straight line through my points. So I know I'm keeping it linear and my answers are correct. All right, that's it. So why don't you give it a try? Go ahead and work on your practice. If you have questions, come see me or watch the video again. Good luck.